Class on Monday was canceled for pretty obvious reasons. So we're a bit behind in terms of the material, and therefore I have a fair amount of stuff that I want to cover today. We're going to spend some time talking about the vector class. In particular, there's the increased capacity method that I'm going to be talking about today that also is in your homework, whatever homework is due this Friday. We're then going to move on to two-dimensional arrays, which the homework that is going to be assigned this Friday, that's the last homework of the semester, and the lab tomorrow is going to be on two-dimensional arrays. I don't know how much we will get to of the two-dimensional arrays. Of course, the original plan was to do the increased capacity on Monday and then the two-dimensional arrays today. That kind of got thrown off track. So that's going to be the plan in terms of the lecture. Homework 8 obviously is due this, homework 9 is due this Friday. We think that it is much better than homework 8, certainly, which granted probably isn't saying much, but we certainly think it's better. And there's, of course, the last lab is tomorrow. A week from tomorrow is going to be a lab quiz. So all of next week we have an exam on Wednesday and a lab quiz on Thursday. And that will pretty much finish up the last week of classes. We're going to be talking about some stuff that Friday as well. So the only other announcement I wanted to mention is there are some people at Xavier University in and around New Orleans that are doing a study. And this particular study requires people both in computer science and not in computer science. I mean, in it as a major, not just in it as a technical class. And essentially what it involves is you fill out a class, fill out an online survey, and get paid $10. If you are interested in this, I have some forms with me at the end of the semester. And the only caveat I will tell you, so it's a worthwhile study. They're studying sort of how a lot of people's knowledge of computer science progresses over the course of a couple of years. You get paid $10. Probably takes about a half hour of your time. I will warn you that like most studies, it takes a couple of weeks for the check to be mailed to you. And being as things in New Orleans are not doing so well today, the basic services aren't there, it may take a month or two for the check to get to you. But if you are interested in, I'll mention this at the very end of the semester, please feel free to swing by after lecture and we can talk about it some more. Other questions, comments, or concerns? All right, so somebody brought up something that I realized I hadn't talked so much about. So we have talked about this whole, this means of going about doing, this arrow diagram. Right, so you have a map, and the map is going to be a two-dimensional grid of locations. It's going to be a two-dimensional array. We haven't seen them yet. I expect we will get to them before the end of lecture today. In each of those spots, I've only have arrows or references pointing to 4 of them, but there would be 100 or however many. There's going to be locations. Each location has a description. Remember the properties from your location class. Each location has a description. Each location has a depot, each location can have a depot. Some locations don't. The depot has a number of properties as well. In particular, a depot has a reference going back to its location. Depot also will have an inventory. And then we have the vehicle class. The vehicle class and the party class, those are the ones that you're dealing with in the current homework. A vehicle also has an inventory. So the inventory class that we write is going to be used both by the depots and by the vehicles. Then we have a party class, which has an array and has a couple people in it, et cetera, et cetera. So the things that I wanted to focus on today is that how do you get the question, and the question I'm about to answer is, given a vehicle, so the vehicle has a location reference, which just refers to, there we go, the particular location that it's at. So how would you, for example, get the inventory of the depot of the location that the vehicle is at? So we know what the vehicle is, right? It's player. So I could say something like, which one? Black. That works really well on a black background. Light blue. I could say, so obviously we have player, because player has been defined somewhere in the game class. So I could say if I want to find the vehicle's location, I could say location L equals player dot get location. And then we're going to have L, which is going to be a reference to that given location. I can then say depot D equals L dot get depot. Obviously have to abbreviate a lot of this. And then we'd have some reference D that's referring to that given depot. And then I could say inventory I equals D dot get inventory. Then we have some I that refers to that inventory. And you notice each one of those I'm getting one layer further on. So I have player already. The get location method from the player class is going to return that particular location. So when I say location L equals player.get location, L is a reference to the location that the player is currently at, one of the locations in the grid. When I say depot D equals L.get depot, well, L is this location, get depot is going to return this, so D now refers to my depot. Similarly, inventory I equals D.get inventory. That's going to, the get inventory from the depot class is going to return the inventory it refers to, so that's going to give a reference to the inventory. So this is one way to go about doing it. Another way, oops, is I could just say this, inventory I equals player.get location. Right, that's going to get the location. Dot get depot. Dot get inventory. And this would all be on one line. That would also do the same thing. Every dot means follow the reference. So here player is this. Dot get location. I'm sorry, player is player dot get location is going to give the location. Dot get depot is going to give the depot. Dot get inventory is going to give the inventory. So if you prefer, you can certainly chain them together that way. And that one line, inventory I equals player.get location, dot get depot, dot get inventory, will follow this chain of references and make I be a reference just to the inventory. So that's another way of doing it. What happens here? Does anybody see a problem with this scenario? I'm sorry? Yeah. So here, I've said player.getLocation, so that's talking about this location here. .getDepot, that's going to give me null. Then from that getDepot, so this getDepot is going to give me null. I'm going to call getInventory, and I'm basically trying to call a method from a null reference. The reason being is that there is no depot object here, because that's what the getDepot would return. This is all null, and from the depot that is essentially null. That's how we keep track of no depots. I'm going to try calling the getInventory method, and that's not going to work. So if you do something like this to get the inventory of the depot that the player is currently at, keep in mind that you have to check to make sure that there is really a depot there before you do this long stream. Otherwise, it's going to give you a null pointer exception. So one way you could do that is you could say, if player.getLocation.getDepot is not equal to null, then inventory I equals that whole long thing. Questions on that? How many people felt they sort of understood that? I'm seeing a good number of hands. Blah, blah, blah. Okay. So last time, oh, we did that already. Oh, no, ignore that. So last time we talked about binary search, and that's where the class ended. And I wanted to spend some time talking about the vector class. Now, we've all seen the vector class. That was in homework 2, I believe. The vector class is quite useful. You just add objects to it, and somehow it magically works. You don't have to pre-declare it as a size. You don't have to tell it how many are eventually going to be in it. You don't have to worry about going over the limit. In an array, if you create an array of 100 elements, you can't put 101 elements in that array. And this is a problem that when you're programming, you often don't want to have to sit there and check every time, is there enough space in my array? Okay, let's make the array bigger. So that's, of course, the nice thing about a vector class is you just add things to it as much as you want, and you don't have to worry about how big that the vector is. It will just allow you to automatically add things to it. And what I'm going to do now is actually develop essentially the vector class that's provided in the Java SDK, and we're going to see how you can automatically add elements to it and not have to worry about the size. It's going to be essentially the increased capacity method that's done in the homework. So, of course, arrays, you can't change their size once created. You create an array of size 10, it is always an array of size 10. You could create a new array of size 20, but your old array can never be changed. So what we're going to do is we're going to create, again, this class. It's called vector, obviously. We're still going to operate kind of like an array. You can still index something by the index number, just like arrays, and it will automatically increase in size as needed. And a couple other things. So obviously I'm calling it vector because that's what everybody else calls it. Okay. So anytime we're designing a class, first we have to think about what properties this class will hold. And this class is obviously going to need something to hold that list of values. As we're going to see, we're actually going to use arrays. So we need to have that array to hold the values. And we also need the number of values in the array. So when we first create a vector, maybe that array is 100 elements. I don't know, it creates an array of 100 elements, 10, 1,000, it doesn't really matter. But we've only stored maybe 4 elements in the array. So we need to keep track of how many elements have actually been inserted into the array and how many entries are probably null. So, and that's pretty much all the properties. Just the array and how many elements are in the array. So we need to figure out what methods or behaviors we want in our vector class. Obviously, we need to be able to put things into the vector and then take things out of the vector. We want to be able to figure out how big it is, how many elements have been inserted into it. We want to be able to print it out to the screen. This is the toString method that I'm going to talk about in a bit more detail. And then, of course, if the array is full, we need to somehow handle that. So if the array is full, we need to be able to magically make it bigger. We're going to see that magic in a minute. So these are the methods in our vector class. Right. So here's our first take on the vector class. It has our 2 properties, an array of objects with a capital O, and an int size equals 0. So I'm going to get to why it's called object in a second. Here we have the default constructor. And what this says is I'm going to create an array of size 100. My initial array has 100 elements in it. If you provide a specific constructor with a parameter, 1,000, 10,000, it's going to make the array be that size. Now you'll notice, of course, that I have the word object there. Instead of an array of strings, an array of ints, here I have an array of objects. I'm not going to get into too much detail about what that means right now. We're going to see that at the very end of the semester. But essentially what this is saying is it can store an object of any class that you create. It can store strings, it can store rectangles, it can store locations, it can store depots, anything that you want, any object that you have created can be stored in this array. Exactly how that works, we're going to get into a bit later. But as far as this vector class is concerned, it's an array of objects, and as we're going to see, the get and set methods take in object objects and return object objects. It gets even more confusing because there's a class, so you can have an object of class, and a class of class object. Right. So the thing to keep in mind is the fact that this object with a capital O there means you can store any object you want inside this vector. Here's the add method. So if we have, if I was to actually draw out my vector, it has the size, well, initially is 0, and the array. The array, remember, is a reference. I know we started at 100. I'm going to pretend it's like 4 because I can draw 4. So this is what it looks like initially, and all those spots are null. If I want to add, what this is saying is whatever is being passed in, I don't know, let's say it's some string object, I'm going to put that in the spot, that size, which in this case is spot 0, and I'm going to increment size at the same time. So then size becomes 1. And notice I have just put into my array 1 element. If I call add again with some other object, size is 1, so I'm going to stick it at index 1, and size then becomes 2. So notice my array is size 4, 100, whatever you want to call it. The array is size 4, but I have only inserted 2 elements into the array. And the fact that we keep incrementing size also tells us where the next thing is going to go. The next one we insert is going to go at index 2. So that's good. But what happens if the array is full? If I have four elements in my array, say I called add twice more. I have 4 elements in my array, and now my array is full. I could try saying array size plus plus equals O, but that's going to try sticking something into index 4, and there is no index 4, right? If there's 4 elements, its index is 0 through 3. So here the problem becomes is what happens if the array is full? So what we need to do is we need a way to make this array grow bigger. And that's through the increased capacity method. This is pretty similar to the one that you're going to be doing in your homework. And I want to actually trace through it to explain how it works. So array is, of course, this array that I'm pretending is size 4, so I don't have to draw out 100 cells. Equals, so into old size equals array.length. Old size is 4. So I'm going to create a new array that's twice as big. So it's a new array of object that's going to be twice as big. So no, that's not going to work very well. One, 2, 3, 4, 5, 6, 7. That's my new array. I've created a new, again, new array is a reference. It points to an array of 8 elements. Then I have a for loop. For I, it's going to go through a total of 4 times and set that particular spot in the new array equal to that particular spot in the old array. What's being copied over is a reference to the new object. So here, array sub I, let's say it's 2. Array sub 2, it's going to copy this reference in here into that same spot in new array. So essentially, both the arrays, the original one and the new one, the first 4 elements are going to point to the same 4 objects. And you'll notice that this also has 4 more spots. So the last thing I say is array equals new array. So that's going to make this array reference refer to that array there. Now you'll notice that this array essentially points to, this array reference points to an array of size 8, twice as big as the original one, that still holds the same 4 objects. So then garbage collection happens. This method finishes. Old side disappears. This gets garbage collected. This gets garbage collected. And that's what it looks like after the method is called. How many people felt they understood this method? Okay, I'm seeing a good number of hands. So the things to keep in mind is that once I create an array, its size can never change. I did not change the size of the original array. It was 4, and until it got garbage collected away, it remained 4. I created a new array of size 8, but the original array never changed size. So that's my increased capacity method. Our add method needs to call that when appropriate. So if our array is full, I'm going to increase the capacity, and then I'm going to put the elements in the array in the appropriate spot. So this last line is what we saw before, but now I'm just increasing the capacity whenever needed. So this increased capacity, you'll notice that that method is not intended to be called by, actually I'll get to that in a second. Yes?
For the increased capacity method, when you call array equals new array, is that within the for loop or after?
That's after the for loop. So this increased capacity method is not meant to be called, is only meant to be called by the add method. And in fact, there is a similar method inside the vector class. I don't know what it's called offhand, but there's a similar method inside the vector class, but you can't actually call it. The vector class will internally call it whenever necessary. In particular, the vector class will call it as needed. So what we are going to do is we are going to make it private. The fact that it is private, all right, so green. The fact that it's private means that some other class that's created a vector object cannot call increased capacity, but add can call it as many times as it likes. So this will allow us to keep adding methods as long as we'd like, and every time keep adding things to the array, and whenever the array is full, it just magically makes the array bigger. It doesn't really magically make it bigger, but from the user of the vector, they don't notice that it's making it bigger. All they know is they add something to that, and there's always space. Question?
Is there any way you can increase the capacity, not just by doubling it, but just adding the amount of space that you'll end up needing? If you need 3 more spaces instead of going to 8, you just make it stop at 5?
So you could certainly, the question was, can I change the amount it increases? And you could, for example, just increase it by 1 each time, but then after you hit 4 elements, every time you add an array, it has to go through this entire process of making the array bigger. In practice, doubling it every time is probably going to be one of the more efficient means of going about doing it, because as you start adding more and more objects, the amount of times you have to call this method decreases. Right? Eventually you're going to hit 1,000, and then 2,000, and 4,000, and 8,000 because it doubles each time. So sure, you could certainly do that, and maybe you would want to do it 3 times the old array size. In practice, I would think 2 times the old array size is probably a good estimate. The array class that they've done in Java, they've actually done studies as to what that factor is, what is the most efficient use of it. 2 is probably a good guess, but I wouldn't be surprised if there are more efficient values for it.
I would actually think about that. Well, I don't know, it's just double the school. I mean, I don't know what the cost in terms of memory. If you add in the cost of objects, it sucks up your memory, right?
Yes. So the question is, let's say this doubled every time, and you want 1,001 elements in your array. And when you hit 1,000 elements, it doubles it and creates a spot of an array of 2,000, the first 1,001 spots that are occupied. So almost half of your array is empty. And it's using up a lot of memory because you have these 999 spots towards the end that aren't being used, and the first 1,001 spots are, because it doubled at 1,000. And this, of course, is the problem that it uses up a lot of memory. Well, that's sort of a drawback. I mean, in a lot of things in computer science are trade-offs. And here you're trading off ease of use, and you're giving up some memory. In practice, computers generally have a fair amount of memory these days. So something like this, you can often get by with using up any amount of spare memory, especially the things that we're doing in this course. You're not going to have a vector that's going to have more than, I mean, even in some of the other homeworks, I don't think we ever had more than 100 elements in a vector. Even if I have all of your names in a vector, that's still 200 or 300, I guess 300 or 400, which is still relatively small in terms of memory. So yes, it does use, it actually wastes a fair amount of memory, but the trade-off is that it's very easy to use. If you wanted to be very memory efficient, then you would just use arrays as opposed to using vectors. Other questions? Okay. So, right, as I said, the increased capacity is only called by the add method. It's never going to be called by anything outside, so we're going to make it private. I actually think the vector class, there are reasons that the outside might want to call it, but I think it's a good example of something, at least as we're implementing this vector class, we're saying that increased capacity is only going to be called by the add method, which is within the vector class, so we're going to make it private. And this way, you can't increase capacity on your own. You can only do it indirectly by adding objects. All right. So this removes an element from a vector. So what this does, so the problem is that if we want to remove this element from the vector, there's going to be a hole. This element is gone, and now there's a hole where you have basically an empty spot. And what we need to do is we need to take everything else, everything further up, and shuffle it down. So we're going to change this vector and instead make it look like that. I've moved the remaining elements down. So if you remove something that is not at the very end of the vector, the elements higher up than that all have to shift down by 1. And that's what this remove method does. This is the item that you want to remove, and we're going to return it at the end. And this goes around and shuffles everything down by 1. This decreases the size, and then we return the original element. So without getting into too many details of the code, that's essentially what happens. If you're moving something in the middle, everything further up has to shuffle down by 1. Okay, questions on this? All right, so.
If you're going to shuffle down, well, wouldn't you? Oh, yes,
Yeah, it decreases the size.
So how about for the for loop up there? Why would you have -1?
What this is doing is it's starting at, all right. So let's draw an array and make it look like this. Let's say that's my vector, and elements, I don't know, maybe they're strings, size is 5, and now I want to remove element in index 1. So first what it's going to say is ret equals array sub which, so ret is going to be a reference to that particular one. Now I'm going to do a for loop. I'm going to start there and go to the end of the list, and I'm going to say this spot is going to refer to the next one. Next iteration of the loop. This spot refers to the next one. Next iteration of the loop. This spot refers to the next one. And that's where the loop ends. It ends at length -1, not length. Sorry, there's one more iteration. That equals that. But now you notice that there's two spots in the array that point to the very last element. Right? Two things point to F. So this, the third from last line, array subarray length minus 1 equals null, that just removes that reference. So that then is the hole. Essentially, the hole that was there is now shifted over. Size minus minus, size becomes 1 less, and then that object is returned. Okay. So, stylus. So this was a, no, guess, there we go. This was a PowerPoint slideshow that was sent to me. Some of these things you've seen, some of them haven't been seen. But I think they're kind of interesting. 10th place.
How like that?
The question is, are these digitally edited? I don't know. I wouldn't be surprised if they're not.
What happens if your suitcase is in the middle? They kind of like it.
Yeah, they're trying to install an air conditioner. So that one we've seen. That one we've seen. And I think we've seen that one. Supported by. I'm curious though if that, I mean, if that propeller isn't spinning, then heck, I'd be out there trying to fix it too. I think we saw that. There is one more, but I think in light of in light of the events of Monday, I probably won't show that other one. So it involved guns, not quite so funny. Okay, so I wanted to talk about a couple other methods as well. Obviously, we want to know how big the vector is. Public int size, return size, pretty easy. Get retrieves an element from the vector, but does not actually remove it, and that's just going to return that particular element. Pretty simple methods. ToString. We've talked about ToString before, and there's two things that are really important to remember with the ToString method. First of all, it must be called exactly public string ToString. If you're getting funky-looking things out of your ToString method, it might be because you didn't call it that. The S in string must be capitalized. Lastly, it must create some sort of string and return it. So this string here, it's going to, we'll try blue today. It starts creating a string with a square bracket and takes the next element and concatenates it onto that string. If we're not at the end of the list, it's going to put a comma in there. So it's nicely comma separated. And then it puts the closed square bracket on there. Essentially, maybe you have a list of integers, maybe you have a list of locations. It's going to write out in square brackets every element in this vector with commas in between them. And then we return that particular string. So we've talked about we've talked a bit about the ToString method. But the reason that ToString methods are really useful is if we look at these lines here, we are just taking, so vector v is our vector. I add a couple elements to it, and then I call some of the operations. And you notice what we're trying to do is we are just printing out v, which is a reference. It's a reference to a vector object. We're just trying to print out v. Anytime Java sees v in a print statement, it will automatically try to convert it to a string because it knows that that's the only thing can be printed out to the screen are strings. And what Java does is it looks to see if v points to an object that has a toString method. In other words, even though we say print out v, Java translates this to print out v.toString. So effectively, it allows us to just easily print out objects. In reality, it's a shortcut that Java puts in there to automatically call the toString method. Then what gets printed out is whatever our toString method returns. If we didn't have a toString method in there, so if this was called, I don't know, toString with a capital T, then Java would look at that as a different method. Java would print out something like this. How many people have seen this? Excuse me, seen this? As I choke on my cough drop. It's going to say vector at 0x32A17F. That means it's a vector object. Ooh, wait, change color. Is that close enough to periwinkle? No, sorry. Well, that's kind of lavender, isn't it? No, sorry. It actually looks more lavender on mine. All right, so what that is saying is it's a vector object at that memory address. So that's actually telling you what object it is and where it is in memory. If you don't put a toString object, if you don't put a toString method in your object, Java puts one in there for you automatically. And what it does is just print out the type of class, type of object it is, and the memory address. So if you don't put one in there at all, or you try putting one in there and it's spelled something other than toString, or it's not public, or it doesn't return a string, or it takes parameters, but it's not that exact line, Java's not going to realize there's a toString method there, and it's going to print out something along those lines. So if you see that, it's because your toString method is either not there or not right. Question?
So in the homeworks, is it okay for us to put in a toString even if you didn't explicitly tell us to?
Absolutely. The question was, can I put in a toString method even if it's not required? Yes. You can certainly put in extra methods. And if you'd like to put in a toString method to help you print out this or that, that's totally fine. All right. So what this does, this code here, as I said, creates a vector, adds the numbers, I think 12 to 29 to it, prints it out, prints out the size, gets something out of it, et cetera, et cetera. You'll notice that whenever we get something out of it, we have to cast it back as a string. The reason is that we've told Java that what's being added to this vector are objects. And Java thinks that they just knows that there are some objects with a capital O. So that's what the get method returns. We saw it on, here we go, it returns object. So we have to tell Java to cast it back as a string. Print out that string, remove an element, remove another element, et cetera, et cetera. And if I run it, this is the same code that we saw there. It theoretically works just as desired. And you'll notice that the fifth element was removed, that's 17, and then 18 was the new fifth element, and that was removed there. So then, this you'll notice, I said it worked, but you'll notice that this actually uses the vector class in the Java util library. And what I can do is I can sit there and I can comment that out, recompile it, and now, assuming I didn't screw something up, it is going to use the vector class that we just defined. And if I run that, it does pretty much the same thing, which is really what we wanted. So the other thing to keep in mind is that when I compile it, you've seen this error message. Uses unchecked or unsafe operations, recompile with xlint unchecked for details. This is something that involves, well, actually I have a slide on this. This is something that involves a concept called generics, which we haven't seen yet. This is actually not an error technically, it's a warning. And those are the particular error messages that we see. And the thing to keep in mind here is that it still compiled it, it still works. You will see how to get around this in cs201, but it's not something we actually cover much here in 101. So you can safely ignore these. They deal with generics. We'll see generics later. So a couple of things about using the vector class. Right, this is just a summary. Whoops, summary of it. So a quick survey as to how we're doing with the vector class. Oh. So what happens if you type in go 41 and go? So nobody's getting any response? Useless piece of crap. Okay, by show of hands, if you're a 1 or a 2, raise your hand. Okay, I'm seeing a good number of hands raised. So, all right. It's called stuff you don't see every day. Oh, actually, this one, he has a bandage over his hand to protect it from the breaking glass. And if you go through it fast enough, you don't feel it. It's only when you don't go, it's like breaking boards. If you don't break it, then you have a big deceleration when your hand hits it. If you do break, you actually don't feel it, especially when you have a big bandage on your hand. I don't know, but I want to find out where that is. I mean, I assume it looks Chinese in terms of the, I mean, no, the architecture does, but if anyone knows what that is, tell me. Well, it could be, but. I don't know, but I'm glad I'm not the cameraman. I think that was the Kursk. It's a submarine that, oh no, I'm not sure if that was Russian or American. There was an American submarine that ran into a mountain. Well, an underwater mountain. They fly. Okay. So I want to spend a bit of time, about 5 minutes left, talking about multidimensional arrays. Tomorrow's lab deals with multidimensional arrays. Again, because of Monday's events, the whole schedule got shifted. We will certainly get to multidimensional arrays before the homework is assigned on Friday. Tomorrow's lab, you are going to be dealing with, so essentially we have a map class that we've talked about. And I'm actually going to pull that up for a second. Right, we have the map class, which is the 2D array. And there are a couple other classes that we've seen. In particular, control and map printer are the two we haven't seen. What map printer does is it's going to go take the map object and print it out to the screen. It's going to print, I think there's a caret if it's a mountain, because a caret kind of looks like a peak, a vertical bar if it's a forest, because it's kind of like a stick, and a period, a period for a grassland, because that's about as empty as you can get a character to be. And the map printer class is going to use, it uses the 2D array, but kind of indirectly. You don't actually have to access the 2D array directly. What you have to do is there's going to be a a get location at method. It takes in a row and a column, and it will just return the location. You're going to see this in homework in homework 10. But essentially what you have to do for the lab tomorrow is just from the map object, call the get location at method, give it a row and a column. It figures out the appropriate location, and then you can tell if it's grassland or mountain or forest. So you are still going to be dealing with the 2D grid, but you're not actually going to be using arrays directly. You're going to be using those methods. And essentially, I just want to show you one or two things. I'm going to go through all this in more detail. Blah, 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 blah. Blah, blah. Right, got it. Here we go. So you could create a 2D array. It looks something kind of like this. You'll notice now it's int bracket, 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 m equals new int 3, 4. So we have two sets of brackets because it's a two-dimensional array. You can have 3, 4, and 5-dimensional arrays if you want. We're not going to see beyond 2. And that creates essentially a table. 3 by 4, 4 by 3, doesn't really matter. This is how you would directly access a given element in the array. From that array M, choose your column, choose your row, and that particular spot is going to hold an integer. Again, in tomorrow's lab, you're not going to deal with that. You're going to call the get location at method, or I forget what it's called, but something similar. And the map class is going to take care of that. It dereferences the array appropriately, finds the given location object, and will return it. So you're still dealing with a grid, but you're not going to actually be dealing with 2D arrays. And that's the 2-minute introduction to the lab. I will see you all on Friday.